All right, everybody. Today's lesson is going to be on working with negative and zero exponents. So, well, we know what exponents are. Negative exponents, okay, just to write down an example, would be something if you have, whether it's a variable, let's just say we have n to the negative 3 power, or if you have a number, something like 8 to the negative 2nd power, okay, where our exponents happen to be negative numbers. Zero exponents is when the exponent is 0, so something like n to the 0 power, or, again, if I use 8, 8 to the 0 power. I have written down here, consider this. There's kind of a pattern that I want you to see here. We're going to start with an easy number. Okay, this is going to help explain our rules for working with negative and zero exponents. So consider this. If I have the number 2, and I want to raise that to the 3rd power. Well, let's think about what that means for a second. That means 2 times 2 times 2. Well, 2 times 2 is 4, times 2 equals 8. Okay, so 2 to the 3rd power equals 8. Okay, now let's just keep going here. Instead of 2 to the 3rd power, let's do 2 to the 2nd power. 2 to the 2nd power means 2 times 2, which is 4. Okay, if I do 2 to the 1st power, well, we know anything to the 1st power is just itself. So what I want us to consider is what 2 to the 0 power is. Okay, so think about that for a second. Okay, one thing you want to notice is this. Our exponent goes down by 1 every time. 3, 2, 1, 0. Okay, and you'll see a pattern here. As it goes down, look at what happens with our numbers. 8 becomes 4, 4 becomes 2. Okay, 2 is going to become, well, what does that end up becoming? Okay, and what you should see here is this. When we do this pattern, okay, every time that the exponent goes down by 1, it's like taking this 8 here, and in this case, since we're working with 2's, okay, it's like our pattern here is that we divide by 2. So if I change from 2 to the 3rd power equals 8, 8 divided by 2 gives me 4, 4 divided by 2 gives me 2, well, what's 2 divided by 2? Well, that's going to give me 1. Okay, so let's look at that for just a second. 2 to the 0 power, so this is 0 exponents. 2 to the 0 power equals 1. Okay, well, that's kind of funky there. Okay, well, let's try another number. Let's just try if it wasn't 2's. Let's try if it's 3's. Okay, I'll change colors here. What if I have 3 to the 3rd power? Well, that's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay, now let's do 3 to the 2nd power. 3 to the 2nd power is 3 times 3, which is 9. 3 to the, well, anything to the 1st power is itself. Well, that's 3 to the 0 power. So again, we have our exponents that are going down by 1 every time. And I want to look at the pattern here. How does 27 become 9? Well, dividing by 3, because we're dealing with 3's. 9 divided by 3 gives me 3. What if I do 3 divided by 3? Look at, we get this 1 here again. So that comes up with our rule. Okay, for 0 exponents, anything to the 0 power automatically equals 1. So I don't care if you're doing 10 to the 0 power, you're going to get 1. I don't care if you're doing x to the 0 power, you're going to get 1. I don't care if you're doing 23 million to the 0 power, you're going to get 1. So anytime you see an exponent of 0, your answer is automatically 1. Okay? Now, let's take this just a step further. Okay? I'm going to go back over to our 2's right here. Okay? Here's where we're at. Now, let's just keep going down. So we had 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st power, 2 to the 0, where our exponents are going down. 3, 2, 1, 0. So next would, if I kept going down by 1, this is when we get into our negative numbers. Well, let's just think here. The pattern was here that we were dividing by 2 every time. Okay? Dividing by 2. Well, what if I take this 1 divided by 2? And I know that you're going to get a decimal, 0.5, but think about writing it as a fraction. 1 divided by 2 is the same thing as the fraction 1/2. Okay? Same thing over here on the right when I'm doing these ones. The pattern every time is that I'm dividing by 3. So if I go down one more and do 3 to the negative 1, 1 divided by 3 gives me 1/3. And you'll see something interesting. When I look at this number here, 1/2, look at the exponent that's on this 2. It's a 2 to the 1st power because we know the exponent is always 1 there if it's not shown. So really what happens was this. When I took this 2 to the negative 1 power, okay, what I really did was, okay, if I write it off to the side here, 2 to the negative 1, okay, is I took this and I moved it to the bottom of the fraction bar. And when I moved it to the bottom of the fraction bar, this exponent that was -1 became a +1. So that's how you get rid of negative exponents. Wherever the negative exponent is, I simply take that base and that negative exponent, and I move it. In this case, I moved it down to the bottom. That exponent became a +1. Same thing here. This is like 3 over 1, but it's 3 to the -1. So I don't want this negative exponent, so what do? Let's move its base and exponent downstairs. We got 3. That became a +1. So that is our rule for negative exponents. So we got negative and 0 exponents. Okay, write each expression using only positive exponents. So this is just a question to get us used to playing around with how we move these. Now the first thing that I notice is these are not fractions. You don't see anything where we have something underneath the fraction bar. We don't see that at all. Okay, but we can make these fractions if we want to, simply by writing them over 1. So really these are all numerators, okay, when we're doing it. Now, what I see right here is a negative exponent. Just like anything, negatives, okay, it's just like your, a personality. We don't want people to be negative, okay? We want people to be positive. It's more fun, all right? So I don't want that to be a negative exponent. So how do I change that from a negative exponent to be a positive exponent? Well, I can change the sign of the exponent if I take the base, which is the 3, and that -5, and really, since this is now upstairs, I want to move it downstairs. So it becomes positive by simply moving it downstairs. Now, if I get rid of everything on top, it doesn't just go away. We're going to end up having a 1 there on top. So write each expression using only positive exponents. Did that. 1 over 3 to the 5th power. I don't have to figure out what 3 to the 5th power is because it didn't ask me to do so. Okay, part B. 16 x to the -6th power y. All right, so really, the only thing we care about is making everything positive, okay? Right now, if you look at all the exponents, the 16 is a 16 to the 1st power, so that's positive. I'm going to leave the 16 alone because it's already positive. The y has an exponent of a 1, so that's good because it has a positive exponent. The one that's unhappy right now, the one that's negative, is that x to the 6th power. That's the one that needs to be moved, so let's move it downstairs. So the only thing we move is the base that has the negative exponent on it, and that -6 as an exponent, when I move it downstairs, becomes a +6. Everything else, the 16 and the y, gets left alone. It doesn't move because it's already happy. It's already positive up there. So this becomes 16y over x to the 6th power. Okay, part C here. First thing that stands out to me is this. We have a 0 exponent. And we should know anything to the 0 power is simply 1. So that becomes m to the 0 power. I'm just going to rewrite it as 1. That's times n to the -4th. Well, 1 times anything is just itself. So that 1 can actually go away. Okay, so I end up with just the n to the -4th over 1. It's unhappy. We've got to move it downstairs and make it n to the -4th. Now, I got to point out here, because all of my examples I noticed were the ones with the numerators. What if I did something? I'm just going to add something on here real quick. What if I had something like this, where the negative thing was on the bottom? Okay. Well, again, the whole point is we don't want it to be negative. Anytime you see that negative, you take its base and itself and move it upstairs. That's how it becomes positive. So if you move it upstairs, that's how you get m to the 3rd. On the bottom, we would have over 1. And then we can just get rid of that over 1, and you get m to the 3rd. So no matter what, I don't care if it's a numerator. If it's on the numerator, then you move it to the denominator to make it positive. If it's already in the denominator and negative, you move it to the numerator to make it positive. Okay, write each expression without using a fraction bar. So they basically, when we see a fraction bar, they want us to get rid of that fraction bar. Okay? Well, the only way I can get rid of the fraction bar is to get rid of the denominator. So think about, how do I move that up? Okay, and if you think you know how to do that, go ahead and write it down. Okay, well, let's expand here a little bit. That 8 is like 8 to the 1st power. And if I move it up, well, I know we usually don't want to make things unhappy. We don't want to make them negative. But because this question specifically says that it doesn't want the fraction bar, we're kind of forced to do so. When the 8 to the 1st goes upstairs, it really doesn't want to be there, so it becomes a negative. Okay? And since it's no longer on the bottom, that would leave only a 1 on the bottom, and we don't have to write it over 1, so it just becomes 8 to the negative 1. Again, normally we don't want to write it as negative exponents, but this question is just getting us used to playing around with what we can do and what we can't do. Okay, we've done a problem like part B already. Simplifying, a to the second power means a times a. A to the third power is a times a times a. So let's just simplify. I can slash kill the a's, slash kill those a's. So really this problem ends up being 1 over a. And the shortcut was, we said there are 3 a's on bottom, there are only 2 on top, so that means that there were more on the bottom there. So 1 over a, that would be to the first. But again, the question says it doesn't want us to use a fraction bar, so we've got to move it upstairs. Basically, if it doesn't want the fraction bar, it means move everything to the numerator. And by moving that to the numerator, that exponent changes its sign. So a to the negative 1. Okay, I got one last problem for us here. Okay, now, this is just combining all the skills that we've already used. Okay, a, 5 to the 10th power times 5 to the negative 6th power. I'll do this one and I'll let you do part B. Actually, even if you want to try part A, go ahead and pause it. See if you can do it. You can come back and compare it to me. So try part A. Okay, you're back. First thing I notice, it says only positive exponents. So I need to get rid of that negative. I get rid of a negative exponent by moving it to the bottom. I'm going to rewrite that 5 to the 10th still stays put, but now that 5 to the negative 6 goes downstairs and becomes 5 to the 6th. Okay, let's think about what that means. That means there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 5s on top, and there are 1, 2, 3, 4, 5, 6 5s on the bottom. And let's slash kill. So those go away, those go away, those go away, and we just keep slash killing. Okay, now what do I have left? I have 4 of them left on top, so if that's 5 to the 4th. On the bottom there's nothing left, which means it's a 1, and that can be simplified then to 5 to the 4th power. Again, the shortcut is, okay, they're both 5s. Which one has more? Well, there are more on top, because 10 is 4 more than the 6. So there are 4 more on top. That's the shortcut if you don't want to write all of that out. Okay, part B. Go ahead and pause it on your own. Give it a try. All right, you're back. So the first thing that I notice, I don't want negative exponents, so that's got to be moved downstairs. So I rewrite. 8 is left on top by itself. On the bottom there was already an n to the 2nd power. Now I have an n, and it became n to the positive 3rd power. So when I moved it downstairs, the negative 3 became positive 3. Okay, so this tells me 8 on top. Now let's just see here. N to the 2nd power is n times n. N to the 3rd power is n times n times n. So let's rewrite. How many n's do I have on bottom? 1, 2, 3, 4, 5 of them. So this is n to the 5th power. That's it. We rewrote them using positive exponents. That's our lesson for today.